Well, hello. All right, so okay, but now we've lost power at the school. So here we are. This is the last opportunity for us to review as a group before the unit test tomorrow. And I have saved for you a really special problem. Okay, this is on page 66 in your unit guide. This is lovingly called the funnel question. And the funnel question. I don't think you're going to find fun in the funnel, but it's a good question. For years and years and years and years and years, area, volume of revolution, volume by cross sections was always on the AP exam. Sometimes calculator active, sometimes calculator inactive. Always, 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 always. It was like 9 points, and like the Southwest average was like 7 points out of 9 for students. Like we were pulling down the points there. In 2016, so not last year, year before, the College Board took a different turn with area and volume and started to decide to do more with area and volume. And last year, it wasn't even on the test. So this topic that was like always on there, last year wasn't on there. The year before was on there in a whole new way that it was devastating for all of the friends. I don't mean like all the friends at Southwest or all the friends at Yes Prep, all the kids across the country. And I happened to like meet with some calculus teachers the weekend after the AP exam, and the calculus teachers were like, what the heck was up with the funnel question? Kids were crying over the funnel question. That's where we're going to spend the last 20 minutes. We're going to look at this funnel question. We're going to do the best that we can, Michelle. It's going to be okay. So here we go. All right. The inside of a funnel of height 10 inches has circular cross sections as shown in the figure at the right. Okay. At height h, the radius of the funnel is given by r equals 1/20 3 plus h squared for 0 less than or equal to h less than or equal to 10. Okay. The units for r and h are inches. Oh my God, we're finally getting units now. Part A, find the average value of the radius. Part B, find the volume. Well, volume. We're good at volume. We know how to handle volume. Part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what's the rate of change of the height of the liquid with respect to time? This is the new area volume question for the College Board. At least it was in 2016. What I want to do is just give you a minute or two. Tear this apart, make sure that you understand what's going on, and then we're going to do our best. No, not physically tear it apart, mentally tear it apart. Grapple with this.
My paper got teared.
I was like, tear it apart.
Okay, apparently Henry's already torn through this. It's a good thing I have extras all the time.
Where's the average value of the radius? You write the average.
Which one?
The homework that was due yesterday that you guys checked today, and the quiz corrections. If you haven't done it yet, please make a pile in the middle of the table with the homework that you checked today and the quiz corrections.
I was gonna make the same joke, but she's older. I was okay with it, but she's gonna make it. She will know it. Yeah. That was my joke. We did it just like
I just remember doing
Anything's possible.
But it will do this and something about a point. No, it was
All right, friends. Part A, find the average value of the radius of the funnel. I'm going to take some hands on this. What ideas are out there? What would you do? You read this floor. What are your thoughts? So they gave you information about the height. They said that told you that the radius is 1/20th, 3 plus h squared. What's your thought for finding an average value of the radius? What do you want to do?
They gave you the value of the height, so can you just plug it in?
They gave you the value for the height?
Give the height.
Okay, that's the height for the funnel, right? The funnel is 10 inches tall. That's what's going on. Yeah, what else?
We find DR, we want the average.
You find DR because you want the average. What other thoughts are out there? Henry, what you got?
You know that the radius mentioned to be like R because it's gonna keep on changing as you go up and down.
Okay, as the water enters the funnel, what's going to happen is the radius gets bigger, 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 bigger. Okay, we're still not there. We got some ideas. Ideas are good. Paul, what are your thoughts? Is it a limit question? And so I think that's what makes this question so hard. There was a time you guys would have found this to be an easy question. And it actually was back in Unit 5 when we were doing things like this on a regular basis. Okay. Find the average value. There is a way in a calculus class that you find the average value. It's been a while. Average value involved an integral. Specifically, if I gave you a function, you would integrate the function and then you had to do something else. You had to divide. You had to divide by the length of the interval. Because when you integrate f of x, that's a total. You're like, add the whole thing up, but then you still got to divide. So for us in our work on part A, if I want the average value, well, average value for what? Average value for the radius. What I need to do is I need to integrate your radius. We're going to integrate the radius, which is 1/20th of 3 plus h squared, with respect to the height, because your radius is defined in terms of the height. I need the limits of integration.
0 to 10.
0 to 10, because I know for this funnel the height can be as small as 0 and it can be as great as 10. Okay, we're almost there. We're almost at average value.
Divided by 10 minus 0.
And then you've got to, depending on how you want to think about this, I heard some people say you want to divide by 10 minus 0. I heard Destiny just say we want to multiply by 1 over 10. Or same thing? Same thing. Just for ease of work, I'm going to put 1 over 10 there. For the calculus kid who got that written down, they get the first point. That was the first point. There's 2 more points, and those come from, can you actually do the integration? Do you know how to find the antiderivative? Do you know how to evaluate? Can you come up with a final number? So take 2 minutes, see what you can do with that. That AP Summit sign-up sheet should be getting passed around.
I was thinking of putting, we equal it to h, like this. Instead of equaling to y, we equal it to h, going in h as well. Yeah.
Lots of options here about how you want to proceed.
Oh, because that's the average, like from 0 to 10. So each
Yeah.
average is 1 to 10.
So I've seen a lot of folks that have said, let me take that 1/20th out in front of the integral. Is that okay?
Yeah.
It's a constant, yeah. So now I've got 1 over 10 times 1 over 20, which is 1 over 200. And now you've got to integrate 3 plus h squared with respect to h from 0 to 10. Integral of 3 plus h squared, what has 3 as its derivative?
3h.
Wait, I heard it from a couple people.
3h.
3h, not 3x. Plus the integral of h squared?
1/3 h.
1/3 h cubed, you're going to evaluate from 0 to 10, and don't forget to multiply by 1 over 200. And if you integrated correctly, first point, they were kind on that part. And then the last thing to do,
Plug in.
plug in. So 1 over 200 times 3 times 10 plus 1/3 of 10 cubed minus 1 over 200 times 3 plus 0 plus 1/3 of 0 cubed. What's that equal to? Nobody cares. Uh-oh, Gerson, what's up?
It's 1 over 20.
It's 1 over 20?
It's 1 over 200, yeah.
Oh, Gerson. Gerson raised his hand and I was like, oh my God, I didn't practice this one enough. Maybe I got it wrong. No, Gerson back there doesn't know that 10 times 20 is 200. Is everybody else okay? All right. So here's what I would hope. Here's what I would hope. I think this part was just mean. Right? This part over here is mean, like a lot of you just didn't even see like what was going on with this part. But my hope is that once you got here, the rest was pretty straightforward for friends, and like this is where we were picking up some points.
Yes.
Okay, good. So keep that in mind. Keep that in mind. All right, part B. Find the volume of the funnel. Enjoy. Enjoy, finally, volume. We know how to handle volume. We do volume all the time.
We know.
You're not going to cry. If you do, I'll make fun of you. Don't cry. Don't cry. You're hapless. Good. Volume. You've got to find volume.
We have to find the base. Base times height. Mr.
Wait, it says circular cross section.
Yep, I think updated.
What's the base? Wait, what's the base? Is this the base or is this the base?
Gonna let you dangle for a little bit here. How do we find volume in calculus class?
Look, this is fun.
And what you're feeling right now was felt by 500,000 students 2 years ago. Volume is something we should be feeling really comfortable with. I heard a lot of folks say, is it solid or is it hollow? Which one is it?
Hollow?
Hollow?
Yeah.
The funnel is hollow?
It's solid.
It's solid.
It's solid.
Jackie, why are you so adamant that it's solid?
Because it's already a three-dimensional figure.
It's a three-dimensional figure, and what's happening here?
It's I don't know.
It's getting filled with water, right? So I mean, like the funnel itself, the plastic piece, if you're thinking about it that way, is hollow. We're gonna fill it with the water. But here's the thing, like normally when we talk about volume, it's either volume of revolution or it's volume by slicing. Is this a volume of revolution question?
No.
Yes.
Some people are having epiphanies, some folks are like, no, it's not a volume of revolution. Marilyn, what are your thoughts here? I see you. Give me a second. Marilyn, what's up?
I think it is a volume of revolution by the y-axis.
If it's a volume of revolution question, which way are you spinning?
What?
You're spinning around something vertical. Right, like I think that's another thing that made this question so darn hard. Folks are like, wait, normally, right, you do questions and it's like, oh, well, here's some function, and you're going to spin around an axis, and I think this is the thing that everybody's ready for.
Sure.
Right, we're 100% ready. Well, what happens? All you do is you look at a slice, and you let that slice spin around your axis of revolution, and what you get are cylinders. Look at this funnel differently. What are we spinning around?
Way.
You're spinning around the y-axis.
Yeah.
So your rectangles have a particular length. Hold on, I see you, Karina. That's the radius. What you need to do to find the volume is it's going to be pi. You're going to do an integral. What are you integrating? You're integrating the radius squared with respect to, whoa, sorry. You're taking the radius. How thick is it? dH. It's the change in height of the funnel that you're looking at, and your limits are going to go from 0 to 10. So it's r squared dH. And you might be worried about, like, wait, we get the r and we get the h, but what's going on here? Well, what do we know about r?
It equals equation 1 over 20.
R is this 1 over 20 times 3 plus h squared. So you've got pi times the integral from 0 to 10 of 1/20th, 3 plus h squared squared dH. This guy here is your radius. In the funnel, there's your radius at any particular time. The height is the dH, and h changes from 0 to 10. So that would be the setup. Now that we've got the setup, finish this off. See what you can do. Karina, what were you going to ask?
Are we gonna make the connection that, it looks like different functions now, like, like this?
Yep. Gotcha. And it's calculator inactive. Because this is a volume of revolution. You're spinning.
The radius, right?
Yep.
No, it's not asking for. It's not asking
So 1/20th times all of this squared. Maybe you want to do a little bit of side work. Can you turn the camera this way? Yeah. So if I do 1 over 20 plus 3 plus h squared squared, that's 1 over 20 times 3 plus h squared. 1 over 20 times 3 plus h squared. 1 over 20 times 1 over 20, well, I think that's 1 over 400. 3 plus h squared times 3 plus h squared. You can multiply those out. 9. 3h squared, another 3h squared, and h to the 4th. You've got to be able to power through. So 1 over 400 times 9 plus 6h squared plus h to the 4th is what you get just by expanding. So you've got pi times the integral from 0 to 10 of 1 over 400, 9 plus 6h squared plus h to the 4th times dH. You could distribute the 1 over the 400 if you wanted to through the parentheses, but oh my god, that is like the worst thing you could ever consider doing. Can you take it out?
Yeah.
Of course you can take it out, it's a constant. Okay, Jesus, if we could go back over there. Okay, so now you've got pi over 400, your integral from 0 to 10 of 9 plus 6h squared plus h to the 4th dH. Finish it off. Don't let this question break you. Just get as much out of this as you can.
Oh my gosh.
All right, if all goes well, that pi over 400 stays right where it is. The integral of 9h. The integral of 6h squared, 2h cubed. The integral of h to the fourth. Add 1 to the power, divide by the new power, 1/5. H to the fifth. Then evaluate from 0 to 10. Plug in the 10, plug in the 0, subtract them all. So now you've got pi over 400. 9 times 10 plus 2 times 10 cubed plus 1/5 of 10 to the fifth. I ran out of room, but then you're going to write minus what you get when you plug in 0. 0. So that's the final answer. Now, in this question, do they ask for units?
No, yes.
Yes.
Tells you
They gave us inches. They gave us units. Are they asking for?
No.
Okay, they didn't actually ask, but what would those units be?
Inches.
Uh-oh.
Cube.
inches.
Inches cube.
It's a volume question.
Inches.
Inches cubed. And what would the units have been for part A? We didn't talk about those. Inches squared?
Inches.
Find the average value of the radius.
Inches.
Inches. So this would be inches. Not sure if they actually asked for the units or expected the units. They would normally say include the units in your answer. All right, part C, it's 9:39, although that clock doesn't say anything at all. Okay, part C, don't worry about it in terms of tomorrow. It is fair game on the AP exam. These are all AP exam questions. Yes. I can post that one. No, I don't write the AP exam yet. I have aspirations.
But for the Thursday,
Oh, the one that you guys are taking on Thursday? You'll be all right. Huh?
Did you write that?
I mean, I typed a lot. The AB, the BC, the AP statistics, lots of typing.